Hi everyone. Uh, Thanks for joining for our webinar series on Introduction to Yarn and Apex as a Yarn application. Um, my name is Ajay. I am an engineer at DataTorrent. Joining us on the webinar is Priyanka. She is a committer with Apache Apex and she is also a software engineer at DataTorrent. Here are some logistics regarding the webinar. This webinar is being recorded. It will be available after the session has ended. To watch again and share with your colleagues who were not able to attend to our session today. The presentation is already available on SlideShare. Please submit your questions throughout the session. You can submit your questions via the questions tab in your console and we will be happy to answer them as they come up or at the end of the session. Without further ado, I will hand over to Priyanka.
Hi, good evening everyone. So I just hope audio is clear and no one has any problem with audio or just seeing my screen. So if anyone has question, please raise it. Ajay or Yogi can help us, who are helping us organize this webinar. Okay, so let's get started. So today I'm going to talk about basics of Yarn, and we are going to see how Apache Apex is a Yarn application. So before I start talking about technical things like what is Yarn, how Yarn is, and how Apache Apex product is a Yarn application, let me take some time to introduce you to Apache Apex. So I understand many of you are new to this product, so it is good to first understand what this product is before we look how that product works as a Yarn application. So let me start. So Apache Apex is actually a streaming platform. It helps you to do real-time processing of your big data using Hadoop platform. I have listed some of the highlighting features of this platform, which will help you to know platform features so that you can choose, so you can decide on for which of your use cases this platform could be useful. So one of the very important thing about this platform, it's very easy to operate. Many of our customer or clients who have used this platform have reported us it has been extremely easy to write application using this platform because we have easy to use APIs, plus we have very ready to use operator libraries. I'll explain details what an operator is, but in short, I can tell you that operator is just some logical code blocks or reusable code blocks which you will need to use in your applications. So we have a very large variety of these operators, as well as we have very simple APIs to use. So writing your applications using this platform is a really easy thing. Scalability, considering we are handling big data and the volume of data could be very high, we are very focused on scalability. So we have options to scale out either dynamically or statically. So based on your incoming load, you can decide to dynamically scale up whenever you have peak load hours, or you can statically configure your capabilities to handle your load based on your business requirements. You can also scale in or scale down again when your load is low in non-critical business hours. So it's a very important feature when you're working on big data. Performance wise, we have considering it's we are analyzing big data, performance is really critical, and we are trying to do it in real time. So we have seen latency of as low as less than 10 milliseconds in our customer environments, and we feel it's a big achievement. So I wanted to highlight this, that we are very good at performance. Fault tolerant, we are working in a distributed environment, so fault tolerance is also a very important aspect. Considering you have hundreds of machines which form your cluster, there are very high chances that some failures are going to happen in your cluster. Your machines are going to go down, your network is going to get corrupt, or your hard disks are going to go down. So all those fault tolerant related problems are handled by platform. As an application developer, you don't have to worry or you don't have to code for all these failure scenarios. statefulness, we do maintain state of a running application so that we can have this fault tolerant behavior. Uh, I quickly talked about Apex Malnar library already. So this is the library of operators which I just mentioned. So we have a vast variety of operators in this library. So to name few, that there are many operators to connect to your external systems, to read data, to write data back to the external systems. Also, variety of processing operators are already available in this library. So writing code is, you can actually reuse most of these operators from our library to write your applications. And last and the most important point for this discussion today, this platform is YARN native. This platform runs on top of Hadoop, and as we progress through the session, you will understand why we say so. Okay, so this is how our technology stack looks like. So at the very bottom, we have our cluster. This cluster is actually a set of machines which can be formed using your physical machines which are available in your labs, or you can choose your virtual machines which you already have in your company. If not, we also provide you facility to use cloud. We support Amazon, Azure, or even we support Amazon EC2 or even Microsoft Azure Cloud and any other if available. On top of that, we need Hadoop. So for Hadoop, we do support plain vanilla Hadoop, which you can download and install on yourself. Or we do also certify of on top of major Hadoop distributors. To name few, we do certify on top of Cloudera, Hortonworks, Pivotal, MapR, and many more. So once you have this Hadoop setup in your environment, you need to install the Apache Apex streaming platform. This is the third layer you need to have in your technology stack to run Apex applications. It's very easy to install this platform. There is a installer provided by DataTorrent. It is called as DataTorrent RTS, and Community Edition is available to readily use. On top of this platform, there comes the streaming applications. These applications are actual places where your processing for your business logic is going to happen. So you can choose to write any application based on your business requirements. You can do security applications. You can do advertisement related applications or e-commerce related applications. We do support almost all variety of applications. Which you can develop using Malnar open source operators. And a very top layer you see is actually provided by DataTorrent, which have developed some UI and other useful components on top of Apache Apex platform. So the one you see, management console, this is a place where you can monitor your applications, where you can maybe control your applications, and this is available freely in DataTorrent Community Edition, DataTorrent RTS Community Edition. Then we also have visualization dashboard and a way to graphically design your applications. These are also part of DataTorrent RTS Edition. Only thing is that they are part of Enterprise Edition. So if you want to try it out, we do give free trial edition for a month or so. So please feel free to go ahead and try this. And on top of all these, we also have REST APIs. So if you choose to develop your own UI, or if you just need to fetch some information from these applications, you can use the REST APIs and fetch the data from the running applications or the platform. I'll just wait for a minute and check if we have any questions. Okay, so the question is, what is the difference between community and enterprise editions from price and features perspective? So I probably can't talk about the price, but the major difference is community edition is totally free. You can go ahead, download, and use it the way you want. I forgot to mention, we also have a startup accelerator program where we actually uh, provide this DataTorrent RTS platform at a very good rates, or I think almost for free. For that, you might have to get in touch with our sales team. And Talking about community edition, it's totally available, totally free to use. You can download and use it for even if for your business purposes. And if you really need a high support and all, you can go for enterprise edition, which I can't talk about price right now. I am actually not even aware of that much. Uh, okay, so I'll go ahead. Uh, so we have just taken a look at how our technology stacks look like. Now I'm going to talk about how Apex application looks like. So this is if you try to imagine how Apex application will look like, this is how it is. It looks like a DAG. DAG is a director acyclic graph, um, where the nodes of a graph represent operators of Apex, and the edges of the graph represent the streams in the Apex. So these let's take a closer look. So these operators are actually a place where your business logic or the processing of data will happen, and the streams are uh, they will actually transfer your data from one operator to another for processing. And the smallest data unit we have, we call it as tuple. So so as per your business logic, you will define your DAG, where you will have multiple business logics called operators, and they will be connected by streams, and data will flow from one operator to another to carry out your business logic. Okay, so we already know now how our stack looks like and how our application looks like, or at least pictorial representation looks like this. Now let's go ahead and start talking about details of yarn. And uh, just a minute, I think we have one more question. Okay, I think you can answer that. Actually, someone is asking for some graphical outputs. Maybe I can take it at the end, or Yogi can point it to the right resources. So let's look into how Yarn is how Apex is a Yarn application. So before that, I'll go one step back and talk about what is Yarn and what is the infrastructure, like what is the design or structure of Yarn. So yarn actually stands for yet another resource negotiator. It's the processing component of Hadoop, which will help us scheduling of your application in cluster, as well as it helps us to do all resource manager of your cluster. So when you talk about a cluster, you will have hundreds and thousands of nodes. So managing all the like memory, CPU, or any other resources, and also making taking decision like where to run particular process, how much memory to allocate to what, all those are taken and coordinated by this yarn. And this yarn helps us to write our applications and frameworks on top of Hadoop to take advantage of this distributed processing capacities. Okay, so this is how I'm introducing yarn. Actually, it's confusing. Like I'm showing you some comparison of Hadoop version 1, which was very famous with the name of MapReduce, and version 2, which is known as Yarn. So though I haven't talked in detail about MapReduce, I'm just going to highlight some features. So when we talk in this way, you will know like what all major changes are done from version 1, and how they are affected, like the way Hadoop works or the way Hadoop is. Okay, the first thing is MapReduce version, which is like version 1 of Hadoop, was known as had a component called job tracker. So what this job tracker did, it was responsible for scheduling each and every application in your cluster, as well as it was responsible for managing each and every task or job related to that application. So let's say when you start one application, you have hundreds of small jobs related to that application. So this job tracker had to manage each and every job of each and every application. Considering this, you can understand that it will be highly loaded because it has to manage a lot many things. And also there used to be only one job tracker, so it was a single point of failure. So scalability and availability were a few of the serious issues. So what version 2 did, they split up this responsibility of job tracker into multiple components. The first one is known as resource manager. I will talk about in details of each of these components, but this is just a brief introduction. Like resource manager manages all your resources of cluster. Then there is application master. This is a per application process. We will see what all it does in detail. And there's a timeline server which manages history or maintains the history of all your applications which have been run in your cluster till now. Then we used to have a task tracker which used to run in each and every machine of your cluster, and it used to manage life cycle of each task. This haven't been changed a lot. It just called as node manager now, and it also maintains the life cycle of each and every process. Only thing is process which it manages is changed. So in version 1 you had either a map process or reduce process. So whenever you want to do any processing, you go to job tracker or resource manager of version 1 and you ask for a map slot or a reduce slot. So please note one thing over here. So you can either have a map or reduce. You cannot have anything else. So this is the only processing capacity or type you had in version 1. Whereas in version 2, you ask for containers. So in version 2, you ask for containers. What is a container? It's just a processing slot actually. So it is normally measured in terms of RAM and CPUs. One thing is like you can actually run absolutely any kind of process in this container. You can decide to run a map or reduce process as well. Also, you can go a lot beyond this and just decide to run some simple commands or some complex logic in this. So container is a very broader term and it has helped us to do a lot more than just map reduce. And this is how many times it is said that Yarn has taken Hadoop beyond batch. So now taking advantage of all these architecture and different infrastructure, you can do a lot more than just batch processing using. I think someone is unmuted. Just a minute. Okay, maybe Ajay can take care of that. Okay, so as we see this in this diagram, so Hadoop version 2, which is Yarn, can do MapReduce but along with that, it can do a lot more. Like it can do graph processing, it can do in-memory computing, it can do streaming applications. Apex is an example of that. Apex is a streaming platform actually. It helps us to write streaming applications, and you can do a lot more. Let's see now how it is possible. So I'll go a little deep into Yarn architecture also. It's important to understand in depth, because unless we understand how the backend infrastructure is, we won't be easily able to understand how our applications run and how a streaming application run on this platform. Just revising, like we already just checked what components this Yarn version has. So let's go in deep and understand each of them. So first one, we have our resource manager, which will help us manage all resources of your cluster. So this resource manager will know like what all processing capacity like in terms of RAM or CPU have on each machine. Also, it will know what is the capacity in use right now and how much is idle or available for new jobs to run. So all this information is available and continuously updated at resource manager. Sorry. Then it also does help you do application scheduling. So whenever you want to start a new application, you need to go to resource manager and ask it to schedule the application for you on the cluster. So resource manager is one of the important components. And in version 2, actually, it can also have a passive standby copy, where if this resource manager goes down, you can replace it and actually keep working without losing any state. Then there is a node manager. This is a per node process. It runs on each and every machine of your cluster, and it is responsible for managing the life cycle of a container. So we just saw in last slide, container is just a processing slot. So any process will be scheduled inside a container, which is associated with like how much memory it has been assigned or how much CPU processing power it has been assigned. So all that will be managed by a node manager, and it also monitors when it launches these containers. It keeps monitoring. It keeps communicating its help to resource manager. That's how a resource manager can keep track of all resources in the cluster. And the last and important is there is an application master process. So please understand this, that application master is actually a per application process. So whenever you want to start application, you need to start application master. And one more interesting fact about application master is it is a customized process. I mean, there is a no generic application master. You have to write application master as per your requirements. So it depends on what you want to achieve. Like application master is a process which knows everything about application you are going to run. So that's why it has to be customized. Depends on what you want to do in your application. And also one more interesting fact about application master is it runs as a normal application process. So all application process are going to be deployed in a container. So like any other process of our application master is also going to be deployed in a container and going to run in on one of the nodes of our cluster. So any questions on this architecture or anything we talked about so far?
There is a question from Rahul. His question is, what happens when a process uses more memory than the allocated memory inside the container?
So actually, it is not possible, because when we launch this process, we do use JVM options to not we, Hadoop uses actually the JVM options to restrict the memory usage. And even if we try to maybe exceed that, then the Hadoop will actually kill that process and maybe reschedule it on some other machine. Maybe considering there could be a resource leak or some other problem. Okay, that's the only question we had till now. Okay, I'll go ahead. Now let's try to understand how a normal yarn application runs. We are not talking about Apex yet. We are just talking about any vanilla plain yarn application. If you want to write it from scratch, how it will look like and how does it run on this cluster which we just talked about. So just assume you have a 3-node cluster. So one of your machine or node will be a resource manager, which will do handling of all your resources as well as scheduling. And you have 2 machines which will execute the jobs where node manager component is running. Now, whenever you want to run any application on in this cluster, you will request that to resource manager. You will ask resource manager to start your application on your cluster. Now, how do you talk to resource manager? Obviously, you need some code to do that. So resource manager actually exposes some APIs using which we can start communication with resource manager. So in a normal case, people start with a Java application which is called as yarn client. You need to write a yarn client process which will talk to resource manager to submit your application. So what does a submit application mean? So when you want to run an application, you tell resource manager that I want to run an application, and you need to give some basic information. You don't need to give all details of your application, like what all you need to do from start to end. You just need to tell about the very first process, which is application master. You need to yarn client will tell resource manager that I need to run an application, and you need to launch application master for me, and you need to run this particular code with this particular configurations on a particular machine, on some machine. So it will also ask for resources, like let's say my application master will need 2 GB of RAM and 1 CPU core to run. So all that information is submitted by yarn client to resource manager. And now applications manager component of resource manager will take this request and will find a slot in your cluster where this process can be spawned based on the requirements. And once it finds some such process, it will launch the application master. Okay, so it will launch the application master. When the application master, when it is launched, the first thing it does, it registers itself with the resource manager. This is important because resource manager need to do some bookkeeping of like where all application master is running, what all resources it has been allocated. So if someone comes and queries resource manager, it has ready answers for all this. After that, application master is the process actually which knows everything about your application. It knows like what all processes you need to start to complete your application, what all resources you are going to need to run these processes. So accordingly, it will contact resource manager and ask for the containers where your processes will be run. So once resource manager get this request, based on the availability, it will come back and tell you, okay, good, these nodes have this capability, you can start your containers over there. Once granted this permission, application master will actually contact individual node managers and request them to start the containers. When the application master talk to his node manager, it also tells it to uh, it also tells it what it needs to do, like which kind of processes it needs to run when it starts the container. So doing this, your application is now actually your all application process has spawned on different machines in a distributed environment, distributed way, and now your application is up and running. It is doing what you're supposed to do, and when it is done, like it will shut down all this process. So I hope this workflow is clear. And if anyone has any questions, I'll wait for a minute and let you know.
There are no questions.
Okay, so I assume this workflow is clear. This is very important for our today's session. We are going to build our next knowledge based on this. Okay, so now let's look into, like, now we have understood what a normal yarn application looks like. Now let's look into how the Apache Apex application runs on top of yarn, or how Apex application runs as a yarn application. Okay. So I am assuming I have a little bigger cluster. I have 4 machines now, out of which 1 is resource manager and 3 are the node managers. And I'm also keeping the we have already submitted an application last site, right? I'm just keeping it for reference. So I would like to highlight one more point over here. So if you have a Hadoop running in your environment, like you already have a cluster and you have Hadoop running, and you had developed some applications in past using MapReduce or anything else. So one of the thing is, you don't need to kill anything or have a new or special cluster for Apex. Your Apex applications can actually coexist with any of your other Hadoop applications. So you can keep running your old Hadoop applications and submit your new yarn applications on the same node or same cluster. Okay, so assume we have all this. Now let's see how how Apex application will run on this yarn cluster. Okay, do you have a question? I'll just wait.
We have 2 questions. The first one is from Arvind. So his question is, once the resources have been allocated, all the other operations are all the other operations taken care by the application manager?
All other
Applications are taken care by.
Okay, so actually, I'll just go a little bit or depth into this. So what happens? Let's say application master has started, and now to complete your application, you need to do 4 operations, maybe read something, process something, and write something, right? So all this processing, that you will obviously write some code for that. So what happens? Let's say your app master has asked for resources of, let's say, 2 GB container each, and you got these 2-3 containers and they're up and running. Now your application master will tell each container what kind of code it needs to run there, what kind of environment it has, what kind of dependencies it has. All that will be provided by app master to yarn containers. So practically speaking, app master is controlling all that, but it is not doing as such, it is just controlling. So it will instruct each yarn container to do some particular thing. Let's say it will ask the first container to do the read task, where it need to open some files, read something. It will ask another container to do some processing, let's say filtering of data, or deduplication of data, or anything. Then we ask third container to write all this output to some database or something like that. So all that will be instructed by app master. So yes, app master is taking care of all operations, but it is not practically doing it himself. He's just coordinating. I mean, he's just ordering all these containers to do that, and it will help. Like if someone needs more resources or someone has any special requirements, it will help them fulfill that.
There is another question by Kaushik. His question is, so like the code for scaling up and down the application, is it written in the application master, and is it custom built for each application?
Okay, so very good question actually. So but yeah, this code to scale up and scale down is I mean, it's controlled by StrAM, and at the code is, I mean, we have the default code, but we very well have the capability in our platform to override this behavior for like the way you want, like for any operator, if you decide to scale in particular way, or you want to have some restriction, or you want to, I mean, scale in particular way, maybe give some particular configuration to one partition and something to another. I mean, there are many things you might want to do other than default risk behavior. So we have all that capability in platform. Okay, so I'll go ahead and start talking about Apex as an application. So, so just repeating the R flow, like very first thing you need to do to submit an application is to start a YAML client to talk to resource manager. So what Apex gives you is Apex CLI, which is a command line interface to talk to resource manager. So now using Apex, you don't have to do any code. You can just use this command line interface to submit your applications. Along with submitting your applications, you can actually configure your application. You can set the properties. You can maybe control to extend, like you can stop your application. You can send it to some commands using this CLI. And this CLI is nothing but just a Java wrapper over the YAML client. The StrAM client, we call it as StrAM client. We have that wrapper over YAML client. So you just need to use this CLI to submit your applications. No need to write any code. So now you know by now, like when you submit an application, resource manager will the first thing it will do is start your application master. So in Apex terminology, we call our application master as StrAM. So I told you in past that app master is a customized code and it needs to be written for each application. So now considering our platform is streaming platform, so we have written application master for streaming applications. So you have need to write. So if you want to write your streaming application, you don't need to write your new StrAM or application master. You can just come to Apex and use already written all these components. Okay, so we call it this application master as StrAM. So it will start on one of the nodes in one of the containers, and it will start take charge of starting your streaming application. Okay, so as we know that next thing it will do, it will talk to resource manager and take some containers and launch them. Now, when we start a container, the very first process which is spawned in these containers is called as StrAM child. This StrAM child process actually helps us to maintain some statistics of application. It will continuously keep talking to StrAM. It will keep sending hardwares to StrAM. It will keep sending some statistics about application or operators to StrAM. And this orange color circles you see, they are actually operators. So we saw that the nodes in our DAG are actually called as operators. And these operators are where actually the processing happens. So if you want to do any processing in your application, all that will be part of our operator. So a container can actually host one or multiple operators. So when we start containers, the StrAM child will host for some of these operators and then start the processing of your operators which is required to complete your application. So this is how the flow of a normal Apex application happens, and this is very similar to what we saw, like how a YAN application runs. That's why we say, like, and actually it runs as a YAN application. If you see, it is nothing but just a YAN application. We take help of Hadoop to run these applications, and we just provide you all the bookkeeping on all the core components which are required to launch your application, manage your applications. All you need to do to write application is code these operators, because these will depend on your business logic. They could be different for every person. That's why these are, like, you might have to write these. If not, like if you find something in your common operator library, you can just, I mean, drag and drop and start using them, or just add it in your dependencies and uh, add it in your application, so you can use it readily. So that's all you have to do, and this is how a YAN application looks like. So we are now going to look into details of each of these components which I introduced, like Apex CLI, StrAM, or StrAM child. Before that, I think we don't have, okay, we don't have any questions. I'll continue then. So I'll just remind, just keep asking your questions. Either we'll take on audio, or if they are very I mean specific questions, we'll reply them on chats. So I'll first talk about StrAM client. So this is actually command line interface, and you can use it. So the script we use to launch this StrAM client is called Apex. It is available in our repository, or if you install Apex, you will get this script in bin folder. So once you start this script, you can launch your applications using launch command. This is all you need to do to start application. You don't need to write any StrAM client code, YARN client code, sorry. You can just use this command launch and you give your application package file. Application package file is actually a package where you have your app master code, your operators code. In this, we don't need app master code in this case because we already have that deployed as part of Apex application. So in this package, you will have all operators code, you will have any config files, dependencies, everything you will package together. And you will give it to the Apex to tell it, okay, do whatever, like talk to Hadoop or do something, just run this config, run these operators for me. So when you actually do that, when you start this, when you launch your application using this command, these are the things which happens actually. So first thing it does, it actually will copy this application package file to HDFS. Now you will ask why you need to copy that. Okay, so we are running in a distributed environment, right? So our processes are going to be launched on any node in your cluster, right? And if you have your application package somewhere locally on one machine, how other machines are going to access it? So HDFS is actually distributed file system. This is Hadoop file system, and it can be accessed from any node in your Hadoop environment. That's why we copy this application package to HDFS. Then we do basic validation for your logical plan. If you remember, logical plan is just the DAG which you had created for your application. Just to clarify like how it will look like, I'm going to take an example which I mean keep repeating or keep explaining in different pages to understand how it happens. So let's say I'm writing an application to copy or read data from our Kafka queue, and I want to write that data to HDFS. So this is my application, reading from Kafka and HDFS. Very simple application. I'll have two operators. One is Kafka reader and another is HDFS writer. Only two operators and a stream connecting these two operators. Okay, so the first thing is it will do a validation of logical plan. It will check if you have any errors, if you are doing any using any incompatible data types or any wrong connections. Let's say you missed to connect the operators using stream, or if you have done any mistakes while defining your logical plan, it will highlight that and it will do early detection of errors for you. So after validation, it will serialize this logical plan again to HDFS, again for same reason that it needs to be accessible from any node in your cluster. And the last thing is it will launch your StrAM application master, which is StrAM in Apex technology. So it will start this very first process, which is called as StrAM. Now, what are things a StrAM does? So StrAM, as we know, it's a streaming application manager. It is actually started inside a container, we will start any other process going ahead. So what all thing it does? What it will do, it will read the logical plan which was serialized by StrAM client. We saw in last slide, right? We do serialize our logical plan to HDFS. So here we read that logical plan in memory and convert this logical plan to physical plan. What it means, it will detail out your execution plan. Let's say you have got this command from outside that you have to read Kafka and write to HDFS, and this is your plan. Like you have two operators connected, and you know what each operator has to do. The physical plan is detailing out of plan, which means let's say because you details could be like, let's say because your Kafka is very fast and HDFS is little slow because it is going to write to disk. So you can say for Kafka, give me 4 operator instances. Like I need 4 Kafka instances and only 1 HDFS instance. So that is like detailed plan. So that is the plan when you feel use when you actually start to execute something on machine. So all that detailing out is done by StrAM based on the configuration parameters and all. Then after that detailing out, physical plan is created, and that is also serialized to HDFS. That is written to HDFS. Then Now your StrAM knows like what all like it knows the physical plan, right? So it knows exactly what all the process it needs to start, what all memory requirements it has. So accordingly, it will go to resource manager and ask it for the resources. Once it gets the permission, and it will start the containers. It will coordinate with node manager and start containers on each machine, and it will spawn this StrAM shell process in each container. Okay, and it also keep watching this StrAM shell, like if they are alive, if they are doing what they are supposed to do, and they use this container manager protocol to communicate. It also keep generating and also accumulating application statistics, like what all containers are deployed for application, what all data has been processed so far, how much data has been processed. All that information, application statistics, is maintained by this StrAM, and it also hosts a web service. So if you want to get these statistics at any point of time, you just talk to this web service and you will get all the data. It also helps in coordinating checkpointing and all. So this checkpointing and all is required for fault tolerance. You need to save state of your application state to restore when something bad happens in your cluster. That is what, like, fault tolerance, you need all that. It also has security support and helps in shutting down or killing applications. Now the third thing is StrAM child. Um, So StrAM child, as StrAM is actually deployed in containers across your cluster. They are started by node manager. So StrAM, when it gets permission from resource manager, it will ask node managers to launch the containers and StrAM child inside your containers. Um, Now, what all things StrAM child does, it will host the operator and buffer server. So we already talked about operators, that compute units are hosted as StrAM child. There's one more component I am just introducing there, that is called as buffer server. So we saw that these operators are connected by streams, and they will keep transferring data from one operator to another continuously. Okay, so this data is going to be transferred on net, maybe because the different containers may sit on different machines which are even not physically co-located, right? So this will be transferred over network, and there could be, I mean, some delays. So you need to buffer this data. So we have a PubSub queue which we call as buffer server, and they actually help us transferring data from one operator to another. So they are also hosted inside this StrAM child, or inside your container. Okay, so that's why the StrAM child is responsible for hosting these operators and buffer servers. Now, what all things a StrAM child does? First thing, it will keep sending heartbeat to StrAM to tell it, okay, I'm alive. Along with this, like heartbeat, in heartbeat you will have some statistics, like, for example, how many records have been processed till now, like or any other information which is required for an application. All this information will be sent by heartbeat to the StrAM, so that StrAM can send this information on web, or publish this information on web service. Then it will also execute any command which is received from StrAM. Common commands are like checkpoint yourself, or kill yourself, or restart yourself. Such commands are entertained from StrAM. Then I just talk about shutdown or kill. So when a StrAM instructs it to do it, it will do it. Then it will also manage lifecycle of operator. I'm not going in depth, but our operator keeps running into some cycle to do your processing. So all that will be managed by this StrAM child. And I just mentioned about buffer server, so it helps us in communication using these buffer servers. So these are like three major components which are introduced by Apex to run your application as streaming application on top of Yarn. I'll again wait for a couple of minutes for questions and answer if anything is related.
So there was this question by Kaushik. His question was, how does Apex handle workload changes on Yarn? And what does a user of Apex need to do in order to build automatically scaling Apex applications?
Okay. I didn't understand how does Apex handles workload changes on Yarn. I'll assume like you're talking about like within the application, if you need more you end up doing more processing or you have more workload, right? Or let's say your input data speed has increased, so your workload has increased. So in that case, the StrAM can ask, or Apex StrAM can ask for more resources to resource manager. So let's say I just took an example, right? So you have Kafka input and HDFS output. So to start with, I had only 2 instances of Kafka input and I had 1 instance of HDFS output. Now for some reason you have started getting, to start with you are getting only 100 records per second. Now you're getting 1000 records per second, right? So of course your only 2 input operators are may not handle that load. So you might need to scale up in this case, right? So in that case, it will, our StrAM will go to Yarn and it will ask, please give me some more containers. Okay, and another the one more question with that was uh, real time batch application leave. Okay, how does it scale up, right? So for that, I already mentioned that we have capabilities in our platform. So either you can have some static configuration saying I need 4 instances, 5 instances, or you can have some custom logic in our operator. So for example, Kafka input, it already has the logic to understand dynamic scalability. So it senses the load of your Kafka queue. It knows that it has to read 1000 records per second now, and it can scale up from 2 to 4 or 8 or any number. And then when you, after let's say a couple of days, your loads goes down. So let's say your Amazon sales were going on, so you had very high input data for a couple of days. So it will scale up to 4, 10 or whatever number it needs for some time. And after the load reduces to 100 per second again, it will scale down. Uh, it will release those resources or containers and give it back to Yarn so that other processes or other applications in your cluster can reuse them. I hope it understands. It solves and it answers your questions.
So his follow-up question was how can a user tell Apex to handle different applications separately?
Okay, so you can do it like it's going in little depth, but there are ways you can either do it using configuration. If not, you want some really custom behavior, you can actually override our operators or write your own custom logic. There are capabilities, there are APIs you can do that, or there are simple configurations. If you're okay with whatever logic we have developed for scaling in, scaling up, scaling down, you can actually just do some configuration and use it. If not, you can override whatever the way you want. So all that capabilities are possible. You just need to tell how what to do. Apex will take care of how to do it. Okay, I think these were the only questions. Feel free to keep asking more if you have. I'll just recap what we saw till now. So, how Apex runs as an application, I'm just going to recap because it was a lot many series of events. Let's do it again. So, first thing is you use Apex CLI to launch your to launch your streaming application. So, you will use this Apex CLI. Apex CLI in turn will communicate with the resource manager and start the very first process, which is application master. And in terms of Apex, it is known as StrAM. So your application master will be started. Your application master will read the plan to execute your application, your business logic. It will read that. Accordingly, it will ask for resources to resource manager and it will launch the containers. So all these containers will have this StrAM shell process, which will host your operators, which are your business logic units. So it will host the operators to do processing required for your application. It will also host the buffer server to help communicate operators with each other. And this is how your streaming application will start running on top of Hadoop using Apex. So that's a summary. Like Apex enables Yarn to run your streaming applications. So if you want to run a streaming application on top of Yarn, don't write your custom code. Don't write all of code yourself. You can use this Apex platform. Most of the commonly used scenarios or bookkeeping things, or most of the things are coded here. You just have to write your business logic only if it is different than what we have. It will take care of all Yarn specific work, and you just have to focus on your business logic. Don't worry about anything else. Actually, Yeah, I just want to quickly tell you, like we have Malla library where we have operators. Also, we have a public repository which is called as examples. It is hosted in on GitHub DataTorrent examples repository, where you can see many application examples are written. So if you have to deal with any external processing, you want to do any processing like parsing, dedupe, uh, or any of such things, you can just go up and look up for examples. 90% of chances you will find something which is relevant to your what you're trying to achieve. And if not, actually you can keep posting your questions on your mailing list. So we have, okay, there it is. Okay, we have users mailing list. If you go to Apache Apex page, you will see that we have mailing list. So subscribe to it, or we actually and all our videos which we keep doing regularly, meetups and webinars, are hosted on YouTube. We also have groups like on LinkedIn we have group, we have meetup groups, we do keep posting all these slides on SlideShare. So feel free to like use whatever mode of communication you prefer. We also use Twitter very heavily uh, to publish our whatever we keep doing. And also you can download Apache Apex using this link, or you can go to DataTorrent site and start using Community Edition. I also mentioned about the Startup Accelerator program. So you can actually get a very like cheap cost, or I think almost free to use this license, enterprise license. So feel free to use this, reach out to these mediums to know more. And I'm going to be here for 5-10 more minutes to answer your questions. So if you have anything, just let me know. And we have more webinars coming. I think one is scheduled tomorrow, which is like how to write your first application, Apex application. So we know like till by this session we know how the workflow of Apex application is. So tomorrow we'll see how to write application actually. Is it ready for version 3? We have not tested with version 3, but I don't see any big. I mean, at least as much as I know about Hadoop and Apex, I don't think there will be any problems. But we have not tried it out yet. Okay, actually we are done. If you have any questions, please ask. We will be here. Uh, Others can actually quit if whatever.